All right, Precalc, we're moving on to some complex numbers, and this is lesson 2-4. You probably worked with these in Algebra 2. I is equal to the square root of -1. Our essential question is, can you add, subtract, multiply, and divide complex numbers? So here's a little example of what complex numbers look like. The square root of -9 minus 5 really is -5 plus 3i. The real part is the first part, the imaginary part is the second. One thing I want to go over is the 4 rotation of I. If we have I, it's just equal to I, also known as the square root of -1. But if I square I, that is -1. If I cube it, it's -I. And if I bring it to the 4th power, that is equal to 1. This rotation, you should know, because we're going to continue to go over it and over it. Remember, when you add or subtract, we're only going to do a couple of these. You can just add and subtract like terms, and you just do this just like you would in Algebra 1 with any variable. So in this case, for A, I would just add 7 and 5, which is 12, and I would add positive 3i and negative 4i, which is -I. Don't forget the next one, you do have to distribute this negative. So we have 3 plus 4i minus 5 plus 2i, and when I add like terms, the real number will go first. 3 minus 5 is -2, and 4i and 2i is 6i. When you're multiplying, you're going to distribute, and we could also FOIL. So for A, we're just going to distribute right through. 8 times 4 is 32, and we're going to keep the I. 8i and -3i is -24i squared. But remember that I squared is a -1. So this is really saying -24 times -1. So I typically just cross this out knowing that I squared is going to change this sign. So now I'm going to write that as the real one that we should. 24, the real number first, plus 32i. And these always happen, this canceling out of the -1 when we FOIL. So look on B, we do have to FOIL. 3 times 5 is 15. My outer terms, 3 and 4i, is 12i. My inner terms, 5 and -I, multiplies to be -5i. And my last terms, a -I and a positive 4i is -4i squared. So there's a couple of things we could do here. The first thing that we're going to do is I'm going to cancel out this I squared. Remember, that changes this sign. So really this is just saying 15 plus 4, which is 19. And then I have a 12i and a -5i where we add like terms, and that's going to give us plus 7i. We'll talk a little bit about complex conjugates. This is what you use to rationalize denominators. So remember that A plus BI and A minus BI, those are going to cancel out. If I was to FOIL these and multiply them, the inners and outers are going to cancel out. So the complex conjugate is a word that you want to know and use. You'll hear that a lot in Algebra 2 and Precalc, so make sure you know that. So what is the complex conjugate for 3 plus I? 3 minus I. Notice we're just changing that middle term. What is the complex conjugate for 5 minus 4i? 5 plus 4i. So now they're asking us to write the quotient. They want us to use the complex conjugate and get rid of this denominator right here. So I'm going to blow it up really large, and we're going to do this together. The complex conjugate of 2 minus I is actually 2 plus I. Remember, I can multiply anything through by 1. So if I put 2 plus I over 2 plus I and I multiply it by this fraction, I can multiply anything through. This is just equal to 1. And I don't change its value. So on the top, first terms, 4. Outer terms are a positive 2I. Inner terms are also a positive 2I. And my last terms are I squared. And I always do it really quickly. I say, hey, remember this is just going to change, and that's just a negative 1. On the bottom, first terms, 2 times 2, 4. My outer terms are positive 2I. My inner terms are negative 2I, and you'll notice those will always cancel out when you multiply the complex conjugate. A negative I and a positive I is negative I squared. And again, change the sign. This will just be a 1. So my final answer, our goal is to get rid of the i's in the denominator, which we did. 4 plus 1 is 5. And 2I and negative 2I, voila, those cancel out. On the top, 4 and negative 1 is 3. 2I and 2I is 4I. So our answer is 3 plus 4I all over 5. Great job. When we work on graphing these, it is a very different thing than we're used to doing. Notice that the real axis is still our x-axis, which makes sense because we put our real points on in the x place, like where we would typically write x. And our imaginary axis in this case will be here. So I'm going to graph negative 2. If I'm to graph negative 2, I would just go negative 2 on the real axis. But what if I was to graph 3i? I would go up 3 on the imaginary axis. I should put an I here on this imaginary axis. And now if I graphed them together, I'll do that in pink, negative 2 plus 3i would be here. So this would be negative 2 plus 3i. The last thing that I'm going to talk about is multiplying. I always have something funny to say when we multiply imaginary numbers. And my key that I always tell you students is to pull out your eyes first. This does matter. I think it sounds funny because you sound like you're pulling out your eyes, but you want to do that. So this is saying I times root 3 times I times, well, root 12 is root 4 and root 3. So remember, I could take this 2 out. So if I multiply, I have 2. I times I is I squared. We'll deal with that in a second. Root 3 times root 3 is root 9. We'll deal with that in a second. Remember that I squared is equivalent to negative 1. And root 9 is equivalent to 3. So the answer to this problem is just saying 2 times negative 1 times 3, which is negative 6. How'd y'all do on that one? We're going to do one more here. We're going to pull out our i's first, but notice we can also take some other numbers out. So for b, I can also take out a 16. 16 times 3. So I'm going to pull my I out. I'm going to take my 16 out. Root 3 will stay. Minus, well, negative 27, I could pull my I out. 27 is 3 times 9. 9 and 3. So the 16 becomes 4. The 9 becomes 3. So this is literally saying 4, the I goes in the middle because that's part of the number. The radical always goes at the end. 4i root 3 minus 3i root 3. That's not a cube. That was part of my root 9. Can these terms be added? Yes, they can. 4i minus 3i is just 1i root 3.